Alright, class. Last time we started talking about gases, and the last thing that we talked about, we said gases have four properties. The four properties are volume, temperature, moles, and pressure. Now what we're going to do in this lecture, I'm going to talk about scientists who figure out what's the relationship between these properties. So we're going to look at what are the relationship between these four properties. The first scientist who came up with this was Boyle. And he has a law after him, Boyle's law. What Boyle's law looks at, it looks at the relationship between pressure and volume. Looks at the relationship between pressure and volume. P1 times V1 equals P2 times V2. That is Boyle's law. And this is, of course, assuming that there is no change in volume and temperature. Okay. Now, the next one is Charles' law. Who came up with it? Charles. Charles looks at the relationship between temperature and volume. And that relationship that he came up with was V1 over T1 equals V2 over T2. This is one guy I like to talk about. It's actually interesting. So he ended up being a physicist and he came up with this. But he actually, his first profession was not being a physicist. And the way that he found out this law, he was a balloonist. What the heck is a balloonist? So have you guys been on a hot air balloon? So there's a guy who operates a hot air balloon, get people in, go up, and then come back down. And that was a profession back in the days, and that was a balloonist. So that's what Charles did. He was a balloonist. So he would have this hot air balloon, go up and down, and then one day he thought to himself, I have to heat this up. I have to heat up the air in order for the balloon to take off. So why is that? And he ended up coming up with a relationship between volume and temperature. He needs to have a temperature, and the temperature makes the balloon to go up and then fill the volume inside the hot air balloon. So it was kind of cool that he was a balloonist, and he ended up coming up with a sophisticated physics equation. All right, so the next one, there are actually two guys who came up with that. So these are about three. And the next one is our Gay-Lussac's law. And the relationship that they came up with, they looked at the relationship between temperature and pressure. And that was P1 over T1 equals P2 over T2. Again, what is assuming? This is assuming that there is no change in moles and volume, the other two properties. All right, last guy. You know this guy really well. You ready? Avogadro's law. Okay, if you had to guess, what kind of relationship do you think he came up with? Relationship between moles and volume. Of course, he's our mole guy. So the relationship that Avogadro came up with is V1 over N1 equals V2 over N2. And this is assuming that there is no change in pressure and temperature. Do I want you to memorize these equations? I do not. And I will show you why I don't want, because you can actually come up with these on your own. Now, these are great 4 different laws that looks at the relationship between these properties. But then finally someone said, why can't we just combine all these together and come up with one equation and one law that relates and shows the relationship between all these properties? And that's what they did. So they came up with one law, and that is, what is that one law? They combined the 4 properties of gases and they came up with one law, and that's ideal gas law, to look at the relationship between these 4 properties. And here's ideal gas law. Ideal gas law is PV is equal nRT. PV is equal nRT. And it sounds crazy, but ideal gas law is for gases. Don't forget that. Now, let's go over units. Units really matter. P is pressure. Pressure has to be in atm. V is volume. Volume has to be in liters. N is moles, you know that. And T has to be in Kelvin. T is temperature, has to be in Kelvin. What is R? That's the only one you don't know. R is ideal gas law constant. R is a constant, and that constant is 0.08206. What's the unit for this? Remember, whatever the unit is, this side has to end up being pressure atm times liter, right? So do this before I give you the unit. What would be the unit for R? It would be atm times liter over moles times Kelvin, right? What would that be? Because then in that case, the moles and the temperature would cancel out. I end up with atm times liter, which is what I want. Okay. Now, I want to show you in a second how they came up with this number. Before I show you that, I need to talk about one more thing. And when we're talking about gases, one of the things that you got to know STP for gases. What is STP? What STP is a standard temperature and pressure. Standard temperature and pressure. Standard temperature and pressure for gases is 0 degrees Celsius, which is 273 Kelvin, and 1 atm, which is also 760 millimeters of mercury. Okay? All right. Now, let's do a fun little thing. What are these? These are not fishes. They don't have eyes. These are balloons. I have 3 balloons, okay? My first balloon, what I have 4 grams of helium. Then I have in this one 32 grams of O2. On this one, I have 20 grams of N2. Grams doesn't matter. What do I need? I need moles. So if I convert all these gram divided by molecular weight, if I convert them to moles, I end up having this has 1 mole, this has 1 mole, this one also has 1 mole. Okay? And these balloons are at STP. Okay? So far so good. And these are at STP. So, because I'm at STP, what does that mean? That means if I'm at STP, I have 273 Kelvin temperature and I have 1 atm pressure, right? So now, because they all have 1 mole and they all are at the STP, 273 Kelvin and 1 atm, they all are going to have the same volume, okay? They're all going to have the same volume, and that volume is going to be 22.4 liters. So, as long as you are at STP and you have 1 mole, your volume is going to be 22.4 liters, regardless of what type of gas you have. It doesn't matter what type of gas you have. It matters how many moles you have. If you have 1 mole at STP, your volume would be 22.4 liters. Okay. Now, having said that, let's go back here. My thing was, let's have a side note, how they came up with the ideal gas law. Okay, now, let's say we are at STP. If you're at STP, okay, and we have 1 mole. Let's say we're at STP and we have 1 mole. Now, we had PV and RT, our equation, and what we're trying to do, we're trying to solve for R. So I'm going to isolate R. So R would be PV over NT. So far, you following me? Okay. Now, we said we're at STP. If you're at STP, then I have 1 atm for pressure. And I have 22.4 liters for volume because we also have 1 mole. N is 1 mole. And temperature is 273 Kelvin. Because I'm at STP and 1 mole, so the volume would be 22.4 liters. So if I plug it in, guess what? Guess what number I get? I get 0.08206. You don't have to know this, but sometimes it's cool to know where these constants come from. So far, so good? Okay, now let's do a practice problem to practice what we just learned. Alright, here is our first problem. So I read this and I go, okay, so this is a gases problem. So I'm going to put the one equation that you know for gases, and that is PV and RT. So I'm going to write down PV and RT. So I'm going to put the one equation that I know for gases. So far, so good? Okay. Now, if I read this, they ask you for liters of carbon dioxide gas. Okay. So liters is what they want. So I'm going to isolate volume. So it would be nRT over P. So far, so good. And then all I have to really do, I have to just plug them in. Now, the hardest part of this question is moles. Do I have moles? Now, I said like a minute ago, I said, this sounds weird, but remember, ideal gas law is for gases. Ideal gas law is for gases. Now, what's the gas I'm looking for here? Carbon dioxide gas. So, what moles do I need? I need the moles of carbon dioxide. But what is given to me? What's given to me is grams of limestone calcium carbonate. So, I need to do, what do I need to do? Hashtag mole ratio. Yes, I need to do mole ratio to get to that. Okay, so what I have is I have 25.0 grams of calcium carbonate. I need to convert it to moles. 1 moles of calcium carbonate is 100 grams. So then the grams, oops, I did not just do that. The grams cancel out. But again, remember, moles of the calcium carbonate is not what I'm looking for. What am I looking for? Ideal gas law is for gases. I'm looking for carbon dioxide. Now, how do I figure out the mole ratio? You already know that. Coefficients are the mole ratio. Coefficients are the mole ratio. So yell the answer for me. Calcium carbonate, CO2. They happen to be 1-to-1. On exam, they will not be. So 1-to-1, again, I use the equation, coefficients are the mole ratio. So what I end up with, I'm going to end up with 0.250, which will be the moles of carbon dioxide. And that is what I want, okay? So I'm going to come up here. For moles, I'm going to put 0.250. Then is R. R is a constant. We talked about it. 0.08206. That is my constant. Okay. Now temperature. The temperature is given to me in 24.0 degrees Celsius. Remember, units is really all that matters in gases. I have to add 273 to it. I get 297 Kelvin. Okay. So I got the moles. Now I have this one. So my temperature is, what do I keep doing that? My temperature is 297. You guys are following me so far? Because again, you have to convert it to Kelvin. Now my pressure, is my pressure okay? Oh no, my pressure is not okay. It's in millimeters of mercury. It has to be in ATM. And again, units really, really matter. So 752 millimeters of mercury, I need to convert it to pressure. 1 atm is 760 millimeters of mercury, right? Okay, so millimeters of mercury can cancel that, and I can end up with atm, which is what I want. When I do that, what I get is 0.989 atm. So again, I just have to convert it to the right unit. I'm going to come over here, put 0.890989 atm. So my final answer, 3 sig fig, is what I should have, is 6.16 liter. So far so good? Okay, not bad. So write down PV and RT and then go from there. Write down PV and RT and then go from there. Okay, ready for our next problem? Let's do our next problem. right, here's the next problem. Again, we know it's a gases problem. And we know every time you have a gas problem, what are you going to write down? You're going to write down PV and RT. Every time you have a gas problem, please write down PV and RT. So far, so good. Okay, now, there are two types of gas problems. The first type is like this. Straight up PV and RT. I'm asking you for one variable, you plug it in. And then there are times what I call these changing problems. And for changing problems, we have to use those Boyle's law, okay, Lusac law, Charles law, Avogadro's laws. That's what we have to use. But I told you, don't memorize those laws. You can figure out based on PV and RT. So it's a changing problem. Does that make sense? Why? Because things are changing. My temperature is changing. Let's see what is changing. If you read the question, the temperature is changing and the volume is changing. The temperature and the volume are changing. Okay? So I'm going to come over here and I'm going to say my volume is changing and my temperature is changing. The rest are not really changing. So I'm going to cross out the rest. Pressure is not changing. It's the same moles and this is just a constant. So far, so good. So it's a changing problem. I read that. Things are changing. The volume, the temperature is changing. It's a changing problem. I'm going to write down PV and RT. Then these are the two that are changing. The rest I can cancel out. Then I'm going to move everything to one side. So I'm going to move temperature to this side. If I do that, I'm going to end up getting V over T. I'm going to move a temperature to the other side. So V1 T1 equals V2 T2. So you did that without having to memorize that this was a Charles law. So you can just do that based on PV and RT. Okay? Now don't forget the unit. That still applies. So what is my V1? My V1 is 5.40 liter is the right unit. Okay? What is my V2? That's what I'm trying to figure out. What is my T1? Again, remember, you have to convert it to Kelvin by adding 273 to it. So my T1 is going to be 288 Kelvin. My T2 is 315 Kelvin. Again, don't forget the units matter. So my V2 is going to be 5.9 liters, 268. Okay? How do you feel about that? Not bad, right? Okay. All right. Are you ready for our next problem? Let's do a couple more problems to make sure that you feel pretty comfortable. All right, pause my video and then do this and then we're going to go over it together. So if you look at this again, it's a gases law. So as long as I have a gases law, what I'm going to write down? I'm going to write down PV and RT. Now, the next thing you have to ask yourself, is it a straight up PV and RT question or is this a changing question? What do you think? This is a changing problem, right? This is a changing problem. Now, what are the variables that are changing? So it's not just a PV and RT straight up, it's a changing. What are the variables that are changing? The volume is changing and the pressure is changing, right? So the volume and the pressure is changing, which means the moles doesn't change, the temperature doesn't change, and this is a constant. Okay, I can cross those out. These are already on the same side, right? So I can write down P1 V1 equals P2 V2. They were already on the same side. Okay, I'm going to plug it in, right? In the same thing that we did over here. Nothing has changed. All right, what is my P1? My P1 is 1 ATM. Is it the right unit? It is. The unit really matters. What is my V1? My V1 is 5.0 liters. What is my P2? That's what I'm trying to figure out. My V2 is 2.0 liters. I could have made it easy for you because I gave you the units are all okay, but pay attention to units. So my P2 is 2.5 ATM. So what does that mean? If I change the volume from 5.0 liters to 2.0 liters, the pressure will also change. You go from 1 ATM to 2.5. So basically, because on the same side, one goes up, the other one comes down. P goes down, the volume will go up because they're on the same side. Ready for next problem? Okay. Here is our next problem. Read this problem and figure out what we do with it. So if you read this problem, you go, this is gases, okay? So what I have to do, I have to write down PV and RT. And this problem is kind of cool. You know how they tell you never tear any kind of hairspray, any kind of can you have, never throw it into a fire? You're going to find out why that is. So PV and RT. So is this a changing problem or straight up PV and RT? Tell me the answer, even though I can't hear you guys. This is a changing problem. Exactly. What is changing? Pressure is changing, and what else? And temperature is changing, right? So the pressure and the temperature are changing. The temperature went from 25 to 402, and I ask you what happens to the pressure. Okay, so the pressure and the temperature are changing. The pressure and the T are changing. I need to move them all to one side. If I do that, then I get P1, T1 equals P2 and T2. So far, so good. Okay, don't forget a unit. Don't forget a unit. What is my P1? My P1 is 4.0 atm. What is my T1? Don't forget. Please don't forget. Degrees Celsius plus 273 gives you Kelvin. To be more accurate, 273.15, but that's okay. Now, what is, so in that case, I have to add 25 to 273, and I get, what do they keep doing that? I get 298 Kelvin. Okay, I don't know what my pressure is going to be, but my temperature reached 402 plus 273 is 675 Kelvin. I'm going to solve for P2. If I do that, I get 9.1 atm. Now, here's the thing. Anything that exceeds 8 atm is going to explode. Anything that exceeds 8 atm is going to explode. Will this one explode? Yes. And that's why they tell you, do not throw any of those spray cans or any of those cans of sprays into a fire, because anything that is gonna reach that temperature, this is gonna be the pressure. Anything that exceeds 8 atm is going to explode. So far, so good. Okay, very nice job. We did a lot of practice problem. I will talk to you guys next time to do more gases.